This section of the course where we will be covering inverse trigonometric functions and equations related to them. Right, so we learned in earlier chapters that functions are, we can define a function whenever we have a one-to-one and onto relationship between the input and the output of the function. Therefore, we should be very careful that we cannot call any domain of the function for its take any domain to be its output. We need a one-to-one relationship. So, for example, taking the sine curve, we know that if we continue sine after pi over the the y values will start repeating themselves, and we have another point where the y value or the output will be the same. So given an input, how can we know which output we want? Do we want this output, or would we need that output? And when we take in an inverse of a function, what we have, the inputs will replace the outputs, and the outputs will replace the input. So the original curve's red curve is the sine curve, and its domain is bounded between negative pi over 2 and positive pi over 2, so that the inverse of this function can be also called a function itself. So arcsine, shown here in blue, is bounded between the value of -1 and +1, because again we needed this domain to be bounded between these values, so that when we take the output, we to be the input of the function. So here, when, for example, we'll give a value of any value between uh, 0 and 1, we'll have a one-to-one relationship between the input and the output here in this domain for the blue curve. And again, we wanted the same one-to-one relationship for any value less than 0 to -1, to have a one-to-one relationship with the output. So that's why we needed to put these boundaries on the domain of x values. We'll have that repeated in the y values. Okay, so the domain of the arcsine is between -1 and 1, and its range is between negative pi over 2 and positive pi over 2. Basically, the domain of the original function is now the range, and the range of the original function is now the domain. So let's look at the arc cos function. We know that the cos function will will repeat itself for negative values of the angle, because cos function is an even function. In fact, one of the identities is that we could replace any negative angle for cos value, and we cos of, for example, cos of negative pi over 4 would be the same as cos over 4. So for this function to take its inverse and have a proper inverse function, we have to make sure that we first of all bound the domain from 0 to pi, so that the outputs are 1-to-1 and onto input and output is 1-to-1, so that its inverse is also have a 1-to-1 and onto relationship between its input and outputs. Because here, as with the other example, the domain basically becomes the range, and the range of the original function becomes the domain of this inverse. So let's look at the next example. the tan curve here. Now the tan curve is already, well, when we take its domain to be negative pi over 2 and positive pi over 2, we already have a perfectly one-to-one relationship between input and output. Here, making sure that don't include the equality signs in the domain, because the pi 2 and negative pi over 2 themselves cannot be included. Therefore, we have a strict inequality here rather than the equality involved in it. And the output, the range of value roots are any real number actually. So the domain of the arctan is any real number, but the range is bounded between negative pi over 2 and positive pi over 2. Okay, so these are the graphs of the arc sine, arc cos, and arctan. So when we take the arc sine of a half, that means inverse sine of a half, we'll end up with pi over 6, which is 30 degrees. Okay, so that's the answer there. So we have been asked in this question to calculate the answer in radians. So when we take arctan of pi over 3, arctan of root of 3, we'll get the answer to be pi over 3. And that's equivalent to 60 degrees if we had to calculate it in degree terms. So arc sine of negative square root of 2 over 2 is negative 45 degrees, which is negative pi over 4. Our answer needs to be in radians. Okay, so noticing that sine is an odd function, we can take the negative, the input, and put it on the outside of the function. This is one of those properties. Therefore, okay, so looking at the final example, we have arc sine of -1 inside the as the input for cos function. So first of all, we're going to deal with the input. What is -1? The -1 arc minus inverse sine of -1 is pi over 2, the negative pi over 2. But because we have that the cos of negative angle is the same as cos of the positive version of that angle, because cos is an even function, is symmetric around 0 degrees. Therefore, any of these angles here, the, our case, in this case, negative sine, uh, negative sine of inverse sine of -1 is negative pi over 2, and cos of negative pi over 2 is the same as cos of pi over 2, which is 0. Okay, with that, I should leave you to um, get on with your practice, and I'll see you in the next section of the course. Have fun!